Hello, everyone. Good morning, good afternoon, and good evening, and welcome to this session. This session is going to be part of the Cloud Native Data Management Day 2021. It's a co-located event with KubeCon US, which is in October 2021. So in this session, we'll be talking about architecting disaster recovery solutions for Kubernetes clusters. And my name is Bhavin Shah. I'm a technical marketing manager with Pure Storage and the Cloud Native business unit inside Pure Storage, which is the Portworx PU. And to help me talk about this topic, I have Ryan Wallner with me today. Ryan, you want to quickly introduce yourself?
Yeah, sure. Thanks, Bhavin. I appreciate it. Also work here in the CNBU or the Portworx business unit at Pure Storage. I'm the manager for the technical marketing team here and excited to be working and talking about disaster recovery with Kubernetes today. So one of the first things that you want to really focus on when architecting disaster recovery within your Kubernetes ecosystem and environments is really about identifying the challenges of disaster recovery, meaning that you have to plan for a disaster to happen in order for you to recover from it in a proper and sort of way that works well with Kubernetes. So some of the biggest challenges that are often related to disaster recovery is around cost and budget. A lot of the times, developing your own tools or hiring the engineering expertise is very costly, or some of the tools that are out there today, you really have to think about them at what works best for your organization. Kubernetes is complex, right? There's a lot of different components within the Kubernetes ecosystem that allow you to deploy your applications. So there's the deployments and stateful sets and operators, PVCs and services, and all these things are part of your disaster recovery plan, meaning how do you get these from your site A to site B in a disaster? Multiple tools out there. Do you want to focus on using multiple tools for every application, or do you really want to have a streamlined process with a single tool? There are sort of backup windows to consider. There's business unit expectations, like what do your different teams and DevOps teams within your business or organization expect? Finally, really understanding your RTO, recovery time objective, and recovery point objective is really important. And that leads me to the next slide here, which is what is sort of RPO and RTO. The idea here around recovery point objective is the amount of data loss measured in time, meaning that if you were to have a disaster occur, whether that's a natural disaster or ransomware or something like that, how much data loss is acceptable? Now, your answer might be none, and that's completely fine, but there are scenarios and applications which can handle these types of scenarios in different ways, meaning that even if your RPO was in the last 5 minutes, we don't recover that data. There's ways to get that data, or if it's mission critical, you need absolute zero data loss. That's something to consider, and these affect how often you take backups or how often you move data from one location to the other. The other piece is recovery time objective, and that's really the amount of time it takes to restore a business process after that disaster occurs, meaning how quickly can you get your users back up and running and access to their data. And this is critical when it comes to getting your business back up and running. Now, obviously, some level of time to get your application back up is probably acceptable if you can tell your users that you've lost no data. But at the same time, there's also, financial applications that can have almost no downtime. So consider these two things very, very closely. Lastly, before I hand it back over to Bhavin, I want to talk about the different, essentials when it comes to the enterprise application. There are a large amount of enterprises out there that have a requirement that recovery should happen in less than 1 hour. It's often that this is not the case. However, even if this is the objective, many enterprises struggle to meet these demands. So, recovery demands are critical to understand. The other part of this is compliance, right? Backup and restore, moving data from one place to another. GDPR comes into play here, and really understanding those backups as an essential component for your GDPR compliance is one example of some of the things you have to worry about there. And then lastly, and I think probably more importantly, and maybe more front and center, is the data protection aspects, right? Preventing the data loss for your users, right? Data loss really means loss of other things like monetary loss. And we all know data loss can really hurt reputation as well as, your overall business in many ways. So Bhavin, I'll turn it back over to you to do some more digging into disaster recovery in Kubernetes and hand over to the demos.
Thank you, Ryan. So like we spoke about why disaster recovery is important for enterprises, but in this slide, we want to talk about how disaster recovery is different when it comes to containerized applications that are being deployed and orchestrated by Kubernetes. Your traditional DR solutions are machine focused. So you can use tools like VMware Site Recovery Manager or like Azure Site Recovery, but they are focused on protecting your virtual machines or your underlying hosts. But when you're deploying containers, each application can be spread across multiple hosts. So your DR solution for Kubernetes should be container granular. It should be able to understand how a distributed application works and is actually deployed on Kubernetes. So it needs to identify all the different components or all the different containers that are running across different hosts and being able to protect them and then restore them in case of an actual disaster event. Your DR solution needs to be application aware. This is important because, again, as we spoke about containerized applications or stateful applications on Kubernetes being more distributed in nature, you need a solution that understands that and allows you to take application consistent and application aware backups rather than just taking crash consistent backup snapshots. You should be able to have a namespace view of your applications. So typically in Kubernetes, depending on your organization, you can either have one huge Kubernetes cluster that is being shared by multiple development teams to run different applications on a per namespace level, or you might have individual Kubernetes clusters for each team. But again, you can have multiple applications running on that. So for your DR solution to work well with Kubernetes, it needs to understand the construct of a Kubernetes namespace and identify all the different Kubernetes objects that are part of your application and it should allow you to create recovery plans for all the components. That means your DR solution should not just be able to protect your application data, which is stored in persistent volumes and the underlying storage system, but it should also help you protect Kubernetes objects like pods and deployments, configuration parameters that are specified as Kubernetes config map objects and Kubernetes secrets. So you need a DR solution that enables you to identify all of these different components and protect your application as a single entity. You need your DR solution for Kubernetes to have built-in automation. You don't want to be in a situation where you had a disaster event and now you are looking at your S3-based backup repository and figuring out which applications need to be restored in which order. What are the prereqs for bringing these applications back online? What order should they be brought back online on? Your DR solution should have a built-in automation that allows you to specify the rules, the recovery rules at the time of configuration. So in case of a disaster event, you don't have to wait for different teams to figure out what's the correct order. Inside your war room, you can directly say that, okay, I need to execute my recovery plan based on the scenario that you're facing. And your DR tool should be able to bring your applications back online. Another critical requirement for a DR solution for Kubernetes is support for multi-cloud. So with Kubernetes being the strong platform that allows you to deploy your applications across on-prem and public cloud environments, you need a solution that works with these disparate environments as well. You need a solution that works with your Amazon EKS clusters, and you need that same solution to work with your Google GKE clusters or your on-prem VMware Tanzu clusters. You don't need again, one of the biggest challenges that Ryan spoke about earlier was different tools, and those different tools adding complexity to your DR plans. We don't need all of that. We need a unified disaster recovery tool that can help me protect all my applications regardless of where they are running. And as Ryan said, like the goal should be zero RPO and then as low as an RTO as possible. So ideally, if you're running mission critical applications, or if you're running applications in production, you will have a requirement or an SLA of zero data loss. So your disaster recovery tool should understand that it should be copying your data across the primary and secondary side. So when it comes time to restore, you can quickly use the automation built into the tool and bring your applications online with a really low RTO. So that these are like a few requirements that you should keep in mind when you're thinking about Kubernetes and when you're thinking about disaster recovery for Kubernetes. So to discuss one such solution in the market, today we have chosen Portworx PXDR. PXDR is part of a complete portfolio of Kubernetes data services offerings from Portworx or from Pure Storage. We have different modules that we'll highlight in different presentations, including PX Store, which is the storage layer for that can be used for your containerized applications, to PX Migrate, that helps you move your applications between clouds as part of any planned migrations. PXDR, which is what we'll focus the demo around today, which helps customers build a synchronous DR or an RPO of 0 and an asynchronous DR with an RPO of greater than 0 solutions for your Kubernetes clusters. And then additional modules also include PX Secure, which helps you provide security, authentication, and authorization for your Kubernetes clusters. And then we also have PX Autopilot, which helps with automated storage capacity management, and PX Backup, which provides a unified data protection or a Kubernetes backup and restore tool for your containers running on any Kubernetes cluster. So without further ado, let's just jump into the demo section. We'll start by talking about Synchronous DR, and we have a demo for you where we have a couple of VMware Tanzu Kubernetes clusters that are running in the same data center but across different vSphere clusters. They can route traffic to each other, they can talk to each other. As part of the deployment, we have already configured a single stretched Portworx cluster across these two VMware TKGS clusters, and we will go ahead and deploy an application on the primary side, perform a failover operation, and move our application on the secondary side, and then do a failback. Let's see what we let's talk about the demo. So we have here is we have two clusters. On the left, you have your VMware Tanzu Kubernetes cluster, like the primary cluster is in red and the secondary cluster is in blue. As part of PXDR configuration, the first thing that we do is generate a cluster pair resource on the secondary side or on the DR side. And once we have that cluster pair object, we edit the YAML file, remove the storage options because the storage replication is handled by the Portworx storage cluster. Well, once the cluster pair is generated, we apply that cluster pair resource on the primary side or our DC1 side. So you can use storkctl get cluster pair command and in the demo namespace and find the look at the status for your cluster pair. Next thing that we look at is a schedule policy. So this is used by PXDR to copy the Kubernetes objects across the two clusters. So your data is being replicated with an RPO of 0, but your Kubernetes objects are replicated at an RPO of 5 because those don't change frequently. Once we apply the YAML file, we can see that kubectl get schedule policy shows us the status. And then one of the important things about PXDR is configuring migration schedule. So here we'll include the name of the cluster pair that we have configured for this demo. We'll include all the resources because we do want to move Kubernetes objects and application configuration. And we don't want to start the application on the other side because we don't want to be in an inconsistent state across the two clusters. And we link our demo schedule policy with it. So we know when our Kubernetes objects are copied to the secondary side. So once we have configured a migration schedule, we'll apply the specification against our primary cluster, and we can use additional commands like kubectl get migration schedule in the demo namespace. We see that the resource is being deployed. We can use additional commands on the primary cluster like describe migration schedule Again, everything will be in the demo namespace. So kubectl describe migration schedule. You'll see that migration was completed successfully. So all of our resources, the Kubernetes objects, were migrated successfully. We'll deploy our application. So right now we don't have an application, and you see that our migration schedule is ready for the migration operation. Let's go ahead and deploy a simple application which has a PostgreSQL backend and a front end where we can generate data by just clicking on the screen and create some Kubernetes logos. So our application configuration looks like we have a persistent volume and a deployment object and a service object for our Postgres backend. So we'll apply that in the demo namespace. And we'll also, at the same time, do a get deploy on the secondary side to see our objects being copied over to the secondary side. We look at the front end object that has a deployment and a service instance as well. We'll apply that again in our demo namespace, and it deploys a deployment and a service object. So on the primary side, it will definitely create the pods that are responsible for the application. But on the secondary side, it will just create the deployment object with the replica count set to 0, because we don't want our application to come online on both sides. Since I'm using VMware Tanzu Kubernetes cluster, I have to create a cluster role binding command so that pods are actually being deployed on the primary side. So now if we do a kubectl get all in the demo namespace, you will see our pods slowly starting to come online. We already have a load balancer IP address from NSXT that's running in our vSphere infrastructure. If I do a kubectl get all in the demo namespace, again, you will see that our front end pod, which is just called the Kubernetes counter deployment, is up and running. Postgres is still in the container creating state. And at this point, I can do a kubectl describe command for our migration schedule and see that like when our migrations are being scheduled and whether they completed successfully or not. So as you can see, all the 7 resources that were part of our application did get successfully migrated from the primary to the secondary side. Volumes are NA here because the storage replication is handled by the Portworx layer. Let's go to the front end of the application and generate some data. So this is our application is running on the primary side, and I'm just clicking randomly to create some entries in our Postgres backend. So we generated some data. Now let's do a kubectl get all on our primary side and get ready for our failover operation. So here we are failing over that application from DC1 to DC2. So we can just do a storkctl get cluster domain status, make sure that everything is in sync before we initiate the failover operation. And then we'll deactivate our primary side. Again, storkctl is a utility that you can download, and it works with kubectl and picks up your kube config from your default location. So once we have deactivated the cluster domain, the 2 sites will go out of sync. So we know that the primary or your DC2 site is the one that hosts the current copy of your data, and DC1, which is deactivated, is not in sync anymore. We'll scale down our replicas just to make sure that there when our application comes online on the secondary side, it doesn't get into any consistency issues. Now let's go ahead and restore our application on DC2. We'll do a kubectl get all. As you can see, there are no pods being deployed right now. We can go ahead and scale our replicas. So we'll scale our replicas to 1 for both the deployment objects that we have. And if we do a kubectl get all now, you'll see that our pods are in the container creating and pending state. So this is where we have an RPO of 0 and an RTO of a few minutes or less than a couple of minutes for this is just the time it takes for the pods to be deployed on our VMware Tanzu cluster. Once the pods are in running state, we can use the load balancer IP on the secondary side and navigate to the UI and see that all of our Kubernetes logos that we had generated are in the same place, which means that the data that we stored in the Postgres backend is actually saved. So you can add more data to it. So your application is back online without any real disruption from a user perspective. So next, let's talk about failing back that application. So we performed a failover from from DC1 to DC2. Now we are failing back the application from DC2 to DC1. So since we had deactivated our cluster domain, we'll activate it again. So storkctl activate cluster domain command. And then once we do storkctl get cluster domain status, you will see that it takes a few seconds to a couple of minutes for the two DCs or for two sites to be in sync again. And once it's in sync, we can resume the migration. So the data that was generated when the application was running on the DC2 site is being copied over to the DC1 site as well. So let's go back to the secondary site and scale down our application because we want it to be running on our primary site again. So we'll use the same commands, kubectl scale replicas for both the deployments and set the replica count to 0. So you will see the pods are in the terminating state. Once your pods are completely down on the secondary site, we can check the cluster domain status and scale up the replicas on the primary site. So same command again, just increasing the replica count to 1 for both the deployment objects. And if we do a kubectl get all in the demo namespace, you will see that our containers are like our front end is already in the running state. Postgres is in a pending state. So it will eventually go from pending to container creating to a running state. Once everything is up and running, we'll be able to access the application using the load balancer IP address that is given to us by NSXT. And we can see that the new data that was generated when the application was running on the secondary site got copied over. So again, there was no data loss when we failed over and failed back the application between the two VMware Tanzu Kubernetes clusters running in my data center. So if I do a kubectl get all one last time, I can see that all my pods are in the running state. I can navigate to the IP address and see that all the Kubernetes logos are there as they should be, ensuring no data loss. But yeah, that's a quick demo of Synchronous DR, on how we can use PXDR from Portworx to perform a failover and failback operation for your applications running on VMware Tanzu. Next, let's talk about asynchronous disaster recovery. So like SyncDR is great, but what if you have Kubernetes clusters that cannot meet the latency requirements of 10 millisecond downtime? Or what if they are spread across different data centers completely? Like one cluster is running on the East Coast, another cluster is running on the West Coast. You can't achieve an RPO of 0, but you would still want a DR plan. So if your entire East Coast data center goes down, not just the Tanzu cluster, you can still bring back your application with an RPO that meets your SLA requirements. So we'll look at how you can configure those RPO settings and how you can perform a failover and operation from cluster 1 to cluster 2. So let's look at that demo right here, the async demo. So we have logged into a jump host that is able to access both our VMware Tanzu Kubernetes cluster. We are logged into the async cluster A right now. It's a simple 1 control plane, 3 worker nodes cluster. We have a cluster pair that we have created already. So we can use the same commands, kubectl get cluster pair in the demo namespace and storkctl. And here one important thing to note is in addition to the scheduler status being ready, our storage status is also ready, because here we'll actually be copying data every time our schedule policy is triggered. So let's deploy our application. It's the same app with the Postgres backend and the Kubernetes counter deployment frontend. So we'll deploy both of those YAML files in our demo namespace, and we'll do a kubectl get all command just to look at how our deployment is going. So here you can see we have a couple of deployment objects, which result in a couple of pods, and then a couple of service objects as well. We have one PVC that's bound to our the Postgres pod, and we have an external load balancer IP again from NSXT. So we can navigate to that IP and generate some data just to make sure that when we fail over the application, there's no data loss. So this is me trying to spell out a demo using Kubernetes logos. Hopefully it looks like a demo, but that's what my attempt here is. So we have now generated some data. Those pixels locations are stored in our Postgres database. Let's look at our schedule policy. So we have a demo schedule policy that's already created for us here. And next, we can talk about how we can create migration schedules for our application as well. So from a migration schedule perspective, we specify the same parameters like cluster pair, include resources is true. Here you will see that we don't have the include volumes is false because we need our migration schedule to copy data between the two sites. So every time the migration schedule is triggered using the demo schedule policy, it does copy the volumes from the source to the destination, or from the primary to the secondary site. And again, start applications is false because we don't want an inconsistent application state. And this migration schedule policy applies to the demo namespace. So everything that's running inside that namespace will be copied over. So let's go ahead and apply that migration schedule in the demo namespace. And we can use the same commands that we have used earlier, the kubectl get migration schedule and kubectl describe and startctl get commands to look at our migration status. So migration schedule at every trigger creates a new migration object, which is what copies over the data from the primary to the secondary site. So right now it's in active state. So you'll see suspend is set to false. And if you look at the migration, it's in progress. It's right now it's copying the volumes. So it's like we had one persistent volume claim or one PVC in our demo namespace for Postgres that's being copied over from the source to the destination site. Let's just put a watch command on it and monitor it till the migration is successful. So describe migration can help you get more details. So here you will see that our service objects, config maps, persistent volumes are successfully migrated. You can get status like, okay, it looks final. It was successful. It copied one persistent volume and 7 different Kubernetes objects from the source to the destination site. So to simulate a disaster event, we'll just suspend the migration schedule. Again, if you actually experience a disaster event, you won't have to do this manually. You can just go to your destination site and activate the migration. But since we are trying to simulate a disaster event, we'll suspend the migration schedule. So you'll see that suspend flag is set to true, and we'll log out of the source cluster and log into the destination or the secondary cluster, where we'll basically go ahead and activate the migration. So let me bring out the commands of kubectl vsphere login. As you can see, we are trying to access the async-cluster-b that's running in my px test namespace. I'll change the context so to use the correct async cluster b context, and then I can access the cluster using my kubectl command line. So if I do a get all in the demo namespace, you will see that the deployment and service objects exist, but there are no replicas or no pods being created for the deployment objects. You'll see that my persistent volume already exists on the secondary site as well. So to bring on my application back online, I just need a simple command, which is startctl activate migrations in the demo namespace. This automatically brings my increases the replica count for my deployment objects to what it is supposed to be. So in this case, it's a simple 1 pod for each deployment. And once the pods are online, we can access the application using the external load balancer IP address that's being assigned to us by the NS60 instance running on the secondary side. So let's make sure that our pods are up and running before we try to access the application. Yeah, as you can see, this is our secondary site. The demo, the word that we had written using Kubernetes logo is copied over from our source to the destination site. So we can say that a failover was performed from our primary to the secondary location using pxdr. So if we do a kubectl get all, you'll see that all the different application components are up and running. Our persistent volume is also is there, and it looks good. So that's a quick demo for async dr that shows how you can leverage pxdr from Portworx to create RPO of 0 or RPO of 5 minutes to move your applications or protect your applications from a disaster event. With that, that's it for this session. We hope to catch you in a different session as part of Cloud Native Data Management Day. Thanks for watching.